Imagine a world where energy was so clean and abundant that it was no longer a limiting factor in the growth of civilization. Governments, research organizations, and companies all across the world are racing to achieve a fusion power breakthrough. It would mean the end of fossil fuels, a technology so impactful, its invention could be compared to man's earliest control of fire. Many critics say it's impossible, but one company believes they've cracked the code.
So David, are you building a machine that will produce cheap, clean, abundant energy in our lifetime?
That's the goal. So Helion Energy is building fusion generators. Our goal is to build 50 megawatt scale generators that generate clean, safe electricity.
According to Helion, your home might be powered by fusion much sooner than anyone expected. But why is fusion considered the holy grail of energy? If you could design the perfect energy source, it would have an inexhaustible supply of fuel, be environmentally friendly, not take up much space, and have a high degree of safety. Fusion power, an experimental form of power generation that harnesses the energy released when two atoms combine, fits the bill. Research into fusion power began in the 1950s, and scientists have been able to fuse atoms in a laboratory setting for decades. But no one has yet been able to demonstrate fusion in a practical way to generate electricity. The potential is enormous. Just 1 gram of Helion's fusion-fueled deuterium contains enough energy to power a home for an entire year, and its supply is virtually unlimited, found in small concentrations in all water on Earth. The fuels considered for fusion power have traditionally all been isotopes of hydrogen, protium, deuterium, and tritium.
And what we saw is that there's some better fusion reactions, and deuterium and a rare isotope of helium called helium-3, and you fuse those together and you make helium-4 and a tremendous amount of electricity.
But what is nuclear fusion? How can just 1 glass of anything contain as much energy as 10 million pounds of coal? To answer that, we must enter the inconceivably small and impossibly strange world of the atom. The atom is the smallest unit of ordinary matter that forms every element in the universe. Every atom is composed of a nucleus and 1 or more electrons. If we zoom into the nucleus, we'll find it's made up of protons and neutrons. Because neutrons are neutral, nuclei are positively charged. If you heat atoms to high enough temperatures, they lose their electrons, forming a hot cloud of charged particles called a plasma. Atoms are always moving, vibrating, and bouncing around. The denser the plasma, the more likely it is that nuclei will collide, but positively charged nuclei repel each other if they get too close. The hotter the plasma, the faster the charged particles move, and the faster a particle is moving, the more kinetic energy it has. When nuclei collide at high enough speeds to overpower their electrostatic repulsion, they can get close enough to be overcome by a stronger attractive force, called the strong nuclear force, and they snap together. When 2 light nuclei combine to form 1 heavier element, the reaction is known as nuclear fusion. This element weighs slightly less than the sum of its parts. The missing mass, or deficit, was released as pure energy, up to 4 million times more energy than burning fossil fuels. To be 1 cent per kilowatt hour, or $10 per megawatt hour. If Helion is successful, how will fusion power fit into the global energy mix?
The need for clean baseload electricity is huge. And we at Helion don't think fusion replaces renewable energy. It's an addition.
Energy production, primarily the burning of fossil fuels, is responsible for most of global greenhouse gas emissions. Initially, fusion power can serve as a zero-carbon alternative to fill electricity production gaps in markets that don't have high penetration of renewables, like developing countries. In areas that already have lots of solar, wind, hydro, or geothermal energy, fusion can become the on-all-the-time, industrial baseload source, replacing fossil fuels, and even nuclear fission power. While modern nuclear power plants are the most reliable, zero-carbon energy source on the grid today, fusion power has many prospective benefits over fission. For one, there's lower potential for catastrophic accidents. Because fusion requires precise conditions that are difficult enough to create intentionally, fusion devices can't melt down like a fission reactor. Fusion uses minute amounts of fuel at any given time, and you can immediately stop the reaction by cutting off the fuel supply. Additionally, fusion creates far less radioactive waste than fission. Spent uranium fuel rods are highly damaging biologically and remain radioactive for thousands of years, requiring complex disposal and storage methods. The radioactive waste products of fusion consist mainly of irradiated components. They're generally less dangerous, and the radioactivity dissipates within 100 years. A safe, low-cost, zero-carbon energy source like fusion can enable exciting possibilities for the future. So what would a world with commercial fusion power look like?
Throughout the world, we see challenges in water. So all of a sudden, desalination plants become really cost-effective and possible to solve some water challenges.
Fusion power can also help ease the transition to electric transportation. It's projected that nearly half of all cars will be battery electric vehicles by 2035. Additionally, the deployment of small modular reactors can allow for flexible placement of power where it's needed most, such as isolated areas or unique industrial applications, like for example, Tesla's Gigafactory.